Okay, good everyone. This is my second video on complex analysis, and this today we're going to be looking at polar form. So, looking at this now, we have the real side rather, and the imaginary axis, the real axis and imaginary axis, and this is our. Let's assume that this is our bi, and this is our a. So this is theta, which is the argument, and this is r, which is the modulus. Do you get it now? That means this is a and this is b. Do you get it now? So now, bringing it to the setting of trigonometry, this looks like a triangle. Bringing it to setting of trigonometry, you have what? Sine theta equals to what? B over r, and cos theta equals to a over r. Do you get it now? Now, making b the subject formula, you have b equals to r sine theta and a equals to r cos theta. Now, you note that r, which is your modulus, is greater than or equals to 0, and your theta is from 0 to 2 pi. 2 pi is 360. Do you get it now? So that means that what? Z equals to what? A. What's our A? R cos theta. And what's our B? Bi. B is r sine theta and your I. Do you get it now? Now, bringing out your r, you have what? R. Bringing out, you have what? R or bracket what? Cos theta plus I sine theta. So now we also know that this is equals to the Euler's constant, which is what? E to the I of theta. So we have this, that means E to the I theta is what? Cos theta plus I sine theta. So we are going to prove that in a minute. You see that r e to the I theta equals to this. So why is this equals to this? You are going to see it now. Okay, looking at this now, you know that what? Z equals to this, and Z is also equals to this. That means this equals to this. So let's prove that this and this are equal. Do you get it now? So where this is the argument and this is the modulus. So now let's look at this now. E to the x, that's a raised to power x. Let's look at the Maclaurin series expression for e to raised to power x is what? Summation what? N starting from 0 to infinity, x raised to power n, and that. And the expression for what? Cos s is what? This. The expression for Maclaurin series expansion for sine x is equals to what? This. Do you get it now? Now let's look at this one now. So let's expand this one. Now divide this one into this one. In this form now, you have what? I raised to power n theta raised to power n over n factorial. Do you get it now? Just like the way we have it here. Now, dividing this one into even parts and odd parts, we have what? 2m, 2m, 2m factorial, and also 2m plus 1, 2m plus 1, 2m plus 1 factorial. Do you get it now? We have divided into even parts and odd parts. We did not change anything there. So now this one now looking at this I raised to power 2m. I square is what? Minus 1 is raised to power 2m. Here also I square, that's I raised to power 2m plus 1 is same thing as what? I square is what? Minus 1 raised to power m, and this plus 1 is same thing as I raised to power 1, so which is what? The I that you have here. Do you get it now? And your theta is what? This, and this one is also what? This. Do you get it now? So having this one now, you see that this one looks like the expansion for cos theta and what? Sine theta. This one looks like the expansion for cos theta and sine theta. Taylor's Maclaurin series expansion for cos theta is what? This. You see that they look alike, and for sine theta is what? This. So we can easily replace this one as cos theta and our I sine theta. That's why this is equal to this. So when you add your r, you see that it's the same thing. So we can easily say that what? You can even say that this one is equal to this, and this one is equals to what? This one also. Do you get it now? Now let's look at some nice cases of what? E to the I pi. Now e to the I theta. Now looking at this one, you have e to the I of pi, that's e raised to power I pi. It can also be written as, you know, this one is same thing as what? Cos theta, that's cos pi plus I sine what? Pi. So cos pi will give us what? Cos pi will give us minus 1, and sine pi will give us what? 0. Pi means what? 180. That's sine 180 cos 180 will give us this, and this eventually give us minus what? Minus 1. Do you get it now? So looking at this one also, you also have I'm going to do one for you. You have what? This one can be written as what? Square root of 2 and this is one is written as what? Cos pi over 4, cos pi over 4 plus what? I sine pi over 4, because pi over 4 here is representing our theta. Do you get it now? So now pi cos pi over 4 is what? 1 over root 2. Sine pi over 4 is 1 over root 2. So multiplying root 2, you have what? 1 plus I. So you also have some nice example here which you can also check out on your own, and you can also go through them. So you also have something like this also. When you have find the polar form, or you say you should find theta or whatever you have to find, or find the polar form. This is the polar form for this. Do you get it now? This can also be written in a form of cos and sine. So looking at this one, you have I minus 1. I minus 1. You draw your Cartesian product and your Cartesian plane, and you have I to be what? To be minus 1, and you have what? 1. You have 1 here, and your imaginary axis as what? Minus 1. So that means that the modulus here, which is what is going to join this one and this one, will be coming from the middle. So you have angle 45 here. So if this one is angle 45, that means from here to this side here is one angle what? 3 pi over 4. Do you get it now? So this way is 3 pi over 4. So that is what you have here. So these are some nice examples that you can go through, and you also have some more examples of this, so you can also try them out. So this is where I'll be stopping for today. So in